Okay, this fifth grade. This is the lessons. So this is day one. We'll see how far we get, and then again, what you can do with these videos is just kind of you can go through, look at certain parts, but what we're focusing on here in this packet, this first part, is fractions. So let's get this all set up here. So we're looking about adding and subtracting fractions, and the first thing is, well, we have to find equivalent fractions to do that. In other words, if we get fractions with different denominators, we have to figure out how to find equivalent fractions so we can make those denominators the same. So let's just take a look at this. We won't read through it, but basically this example is just talking about three different equivalent fractions, and there's two ways to do it. So you have two ways to find an equivalent fraction, and we'll be using those for common denominators too. So one is you can do a model, just draw a picture like of a pizza, and two, you can use multiplication. So for example, this model, you got a pizza, and you've got, pretend like this is a pizza, and it's cut into 4 parts. That's our denominator. Tells you how many parts to make a whole, and we have one piece of pizza, or 1 part shaded. So if you want to make an equivalent fraction, you just take your pizza and cut it up. So in this case, they cut everything up in half. So they took this first part and they cut that in half. And then whenever you do cut a pizza, though, you have to sort of pretend like you're cutting the other slices, even though they're not there, because they all have to be the same size. So if you cut this one into 2 smaller pieces, you have to pretend like you're cutting these, right? So now, instead of 4 to make a whole, you have 8. And instead of 1 big slice, you have 2 little ones. There's your denominator and your numerator. That's all. So that's cool. Now they have 1/4 is equal to 2/8. But you could cut it even more. And basically, look at the multiplication here. When you cut it in half, you're doubling the number of slices to make a whole, and that's what's going on here. You just doubled the number of pieces. So 4 times 2, we now doubled it to 8. And of course, instead of 1 big piece, we doubled, by cutting it in half, we doubled the number of pieces. Now, remember, they're smaller, so it's the same amount, but we doubled the number of slices. So what's going on down here? Something similar, and yet different. We're going to cut this one into 3 parts. Now we got to pretend like we cut them all into 3 parts, right? Now our pizza doesn't have 4. We cut them into 3 parts. We tripled the number. Tripled it. Look at this. Here's 3, 6 in this part, 9, 12. That's where the 12 comes from. And instead of 1 big slice like we have up here, we have 3 little slices. We tripled it. That's why it's times 3. So 1/4 is also equivalent to 3/12. Okay? So you might say, well, what's the big deal with that? Well, if you're in the pizza business, it's a big deal. And also, if you have to add fractions with different denominators, you're going to see that's a big deal. Okay, let's look at the next one. So 3/5 of the whole is shaded here. So we've got 3/5. Divide the model into different number of equal parts to find an equivalent fraction. So we're just going to cut the pizza. So for example, if you cut it one time, if you cut that pizza one time, let's take this part off here. Take that off. Then you would have how many parts to make a whole now? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 to make a whole. And instead of 3 big pieces, now you doubled it, you have 6. So really what we did was we doubled the number of slices to make a whole. And when you double the number of slices by cutting it, you also double the number of pieces you have. Of course they got smaller, but it's the same amount, 6/10. Write the missing numbers to describe the equivalent fraction you found in problem 1. Okay, well we did times 2, 6/10. There are blank times as many shaded parts. Well, 2 times as many. there are 2 times also as many equal parts. I'm going to put here to make a whole. They really should have that down there, to make a whole. Okay, let's keep going. Shade the model to show 2/3. Okay, so again, here we have a round pizza, if you like round pizzas, and here it's cut into 3 parts. We're supposed to shade 2, but my highlighter never works. It never works. I don't know why. I'm gonna have to do something about that. Okay, so we shade it. Let's pick a light color. Shade in with this. Whoops. Shade in 2. So there, I'm shading it in. It's a pretty light color. I'll shade in 2 of those bad boys. There we go. And I got it. Okay. Look at the model. So we did this part. Oh, we have to divide the model to show 6 equal parts. So we have 3. So if we cut all these guys in half. Oops, not a really good at cutting that, but pretend they're perfectly equal. Now we have 6 parts to make a whole, which means that's going to be our denominator. Look at the model in number 3. Write the missing numbers to show the equivalent fraction you formed by dividing it into 6 equal parts. So the new fraction was 6 equal parts. 6 parts. I'm going to come over here to make a whole. So in other words, the bottom of our fraction is going to be 6. And then we have 1, 2, 3, 4 parts shaded in. So 4 parts out of 6 parts right here. Now remember, we cut them in half, so we doubled the number of pieces to make a whole. And we also, whenever you do that, you do the same thing to the number of slices you have. That's why people will say, you know, whatever you do to the denominator, you do to the numerator, which is fine. I just want you to know why you do that. Okay, because you're cutting the whole pizza. Explain how you can multiply to find an equivalent fraction. So you might want to say something like, you know, if you you multiply the denominator and the numerator by the same number, you will, create an equivalent fraction. Okay, that's all you got to do. I could have also said 2/3. I could have multiplied. I could have tripled the number of slices. That means I would have cut the whole entire thing so that there was 3 times as many slices, which means whatever actual slices I have, I also would have tripled. And that would have been 6/9, and that would have been equivalent also. Okay, I'm going to keep going. Remember, you can always stop the video and go back, but I'm going to keep rolling along here. Choose yes or no to tell whether the fraction is equivalent to 2/5. Okay, so 4/10. We're going to come down here and we'll test it. 2/5. Let's test it. 4/10. So if I double the number of slices, I also double this. Oh yeah, that one works. Okay, that one works. Let's try another one. Let's try the next one here. Let's try 5/8. 5 times. Oof. 5 times. No, I can't. Even if I just double the number of pieces, I'm going to have 10. So this one doesn't work. There's nothing I can multiply. Okay, that one does not work. That's a no-go. It's a no-go on that one. All right, here's 6/15. So this time I'm going to have to triple the number of slices to get 15 slices. And if I triple the number of slices I have, bingo, that's a go. That's a go right there. That works. Okay. Let's go to the next one. 6/20, right? So 6/20. I got to quadruple the number of slices in the whole pizza, and if I quadruple this, 2 times 4 does not equal 6. That is a no-go. It's a big negative. Negatory, catchatory. 10/25. Here we go, 10/25. Is that one going to work? If I do 5 times the number of slices, I can get 25 slices to make a whole. And if I do 5 times more slices than here, 10/25 works. Now remember, they're going to be really small slices, but they will be equivalent. So that works. So that's probably the easiest way to do it. You know, technically you could have, you know, tried to chop this up here. Say if I want to try this first one, I could have said I have 5. If I cut it once, double the number. You can see that's 4. Okay. If I wanted to test out this one here, 6/15, I could have said, well, I got 5. What if I triple the number of slices? I'm going to have to, so you're going to cut it 2 times, and that will triple the number of slices, right? Now you have 1, 2, 3 up, and then 1, 2, 3, 4, 5 across. So that would give you 15. So you can still do it by drawing, okay? Number 7, how did you determine whether a fraction was equivalent to 2/5 in this problem, number 6, okay? So what we did was, and there's different ways to do it, but I tested each one. So I tested each fraction, and what I did was just by multiplying, whoops, the numerator and denominator. By the same number. And whenever you're doing a written explanation in math, it's always a good idea to say, for example. Examples are just good. For example, 2/5, if I do double it, okay? So again, you know, you want to write complete sentences. You really do want to practice writing these explanations, because basically that's what you got to do in the world. I mean, you don't, you know, anything's got to, any work's got to have a written explanation to it. You go to get your car picked up at Tom Pratt's, for example, and you know that you want to see, well, show us your work. What did you do? So I'm going to pay this big bill. What am I paying for? So it's a really good, important skill. All right. That brings us to day 2, so that is a wrap right there. So day 1, quick video. The only other thing you have, let me pause this. The only other thing you would have would be the Fluency page, and the Fluency is just, let me pause it again. Okay, and here is the Fluency page, and we can go through these, and you can check your work. And we're just going to use the standard algorithm at this point. So 1 times 8, 8, 1 times 6. Now I'm going to move over from the ones place. This is like a place value chart. This is the ones place over into the tens place. 6 times 8. And again, if you weren't sure on a separate piece of paper, you could write like 6 times 1. This is a great way to do this. 6 times 2, 6 times 3. You could write all that down and then have those facts there. 6 times 8 is 48. So I'm going to put 8, carry 4. 6 times 6 is 36 plus 4 is 40. So then I add up these two partial products. So the first one's 4,148, yay. And then I would stop it, you know, check your work. If you haven't done these, do them first, okay? And then you can just use this part as your check. All right, 5 times 9, 45. 5 times 6 is 30, plus 4, 34. I'm going to cross this off because I don't want to get confused. And I'm going to put a 0 here. I'm going to now go into the tens place. 2 times 9, 18. 2 times 6 is 12, plus 1, 13. Add my two partial products. 4 plus 8. 3 plus 3, 6, and 7. My full product is, whoops, that's a weird looking 5, right? Whoops. 1,725. And again, you know, do this work first and then check it. Pause it, do the work. Here's 21 times 21. So which, by the way, we could write with exponents would look like this, 21 to the power of 2. Aha, we got exponents coming up here at some point. So that's an exponent. That means 21. It's the same thing as 21 times 21. Here we go. 1 times 1. 1 times 2. Put a 0 and move over. 2 times 1. 2 times 2 times 2. Add the partial products. 441. Last one. 9 times 5. Again, pause it if you haven't done it yet. Pause it and then come back and check. Don't just copy them down. That won't help your brain at all. 9 times 5 is 45. 9 times 3. And again, you can write, on a separate piece of paper, 9 times 1, 9 times 2. You can get all that down there. So you're all set to go with those facts. Great strategy. 9 times 3 is 27 plus 4. Okay, is 27 plus 3 is 30. So plus 4, one more is 31. And I cross this off like that, okay? Because I'm not going to use that again. Now I'm going to put a 0 in the ones place, move over to the tens. 4 times 5, 20. Carry 2, that's a 2 there. 4 times 3 is 12, plus 2 is 14. Add my partial products, 5, 1, 7, 1. Ladies and gentlemen, that is a wrap on the day 1 festivities. We'll see you for day 2. Goodbye.